So looking on towards the vocabulary of algebraic properties, we want to apply what we have been learning through your guided reading about the algebraic properties. So first of all, what I want to notice with part A is that I'm adding two things together. I'm adding two things together. So I know that this is addition somehow or another. So this is some property of addition. And I'm going to notice that it just flips the order here. So I've got two things equals two things, but the order is flipped on either side of that equal sign. So instead of 5 plus 2, I've got 2 plus 5. So that is the commutative property of addition. So how do I know it's commutative? Because if I'm driving a car, look, here's my car, okay? If I'm driving a car to work and then I drive it back home, okay, I start at home and I go to work. Then I start at work and then I go home, and that's my commute, okay? So that's the commutative property. That looks more like an octopus than it did a car. Okay, so let's try this one. I've got the same thing. So what's the operation first? I've got multiplication. And then I've got two things on this side. I got two things on this side being multiplied together. We call those factors. So I've got two factors on this side and two factors on this side. But I'm going to notice they match identically except for the order is flip-flopped. So 5 times 2 is 2 times 5. So again, my commute has flipped. So this is the commutative property of multiplication. Okay, so now we're going to ramp it up a little bit. First of all, I know this is addition. Okay, there's addition on this side, there's addition on this side. So what is the purpose of those parentheses? The purpose, it's easier to see over here, is addition. So I'm grouping something together. So first of all, we know that this is addition. Addition, okay? And now I want to notice something else. The order has not changed at all. So this says 2, 3, 5. This says 2, 3, 5. So the order is the same. So think about associating. On this side, the left two terms are associated with one another. On this side, the right two terms are associated with one another. So this is the associative property of addition. Okay, the associative property of addition. So the order did not change at all. The order will change with commutative property. The order will not change with the associative property. So let's look further down. First of all, how's it connected? What are we working with? I've got 3 terms being multiplied. I've got 3 terms being multiplied. So I know that this is multiplication. And then what do I notice is the same? The order is not different. I've got a 2, 3, 5. What's different is what has been associated together. So on this one, the left two factors are together. On this one, the right two factors are together. So why does it matter? Go back to order of operations. Order of operations would say to multiply this together first and then multiply by 2. But you'll notice that it's the same thing as if I multiply this together and then multiply by 5. Either way, you'll get 30. So this is the associative property of addition, or sorry, of multiplication. Okay, so now I want to look again. What's going on the left? Well, I've got multiplication. I've got 2 times 3 plus 5. And when I look at that 2, I notice that he has been taken to both the 3 and the 5. Okay, so I distributed him. That's one of the properties that pretty much everybody recognizes. So it's distributive property. And if I asked you what to do, if I just covered this side up and said, hey, what do I do to that? You would say I would add those two things together. But what happens if you couldn't? Then you would say I would distribute the 2. Okay? So let's come up here. And what is this one going to be? So I've gone from a multiplication problem to an addition subtraction problem. Same thing with down here. I went from a multiplication problem to an addition subtraction problem. So I bet I'm going to distribute. So I've got 2 times 3 and 2 times 5. So 2 times 3 minus 2 times 5. So again, this is the distributive property. And now I would like to know what this is. And this is going to be the additive identity. In other words, I can add 0 to anything and it doesn't change what it is. So looking at this, 3 plus 0 is just 3. Adding 0 didn't change anything at all. So your additive identity is 0. Identity means it's the same thing on both sides. So what would I add to any number to get itself back? I would add 0. So this is an example of the additive identity. So let's take a look at this one. I've got 2 times 1 is 2. So this is going to be an example of the multiplicative identity. So what do I multiply times anything to get itself back? I multiply it by 1. So the identity means that the left and the right are equal. And then you're telling me what to multiply by to make sure nothing changes. So I would multiply by 1 to make sure that nothing changes. And now let's see how these two things are related right here. Okay, the additive identity from part G. And I'm looking at addition subtraction on part I, just kidding. Part I. And this is saying, what do I add to 3 to get the additive identity? What do I add to 3 to get 0, which is the additive identity? I would add the opposite. So this is the additive inverse. Okay, it's the additive inverse because I just take 3 and change his sign and I get 0 for an answer. So take this number, whatever it is, and change its sign, add it together, and you'll get 0. So if this was negative 175 plus positive 175 would give you 0. And then finally, this is going to be your multiplicative inverse. In other words, what do I do with multiplication in order to get an answer of 1? So remember that I can write 2 as 2 over 1, and all I did was flip it. So it's called the reciprocal. So this is the multiplicative inverse. So what do I do to the first number when using multiplication so that I can get an answer of 1? I flip it and I use the reciprocal. So let's spell reciprocal real quick. Reciprocal. And that is it.